Hello everybody, and welcome to the channel. I'm Michael, KE4EST, and today we're going to look at this Heathkit T-3 signal tracer. So let's bring the camera on in a little closer and have a look. This is one I've been looking for a while, so I was kind of excited to get this one. And it's pretty good shape, it needs some cleaning, you can see. But the outside's pretty good shape, so let's hope the inside's in good shape. But if not, if you have to modify or make it work, at least the outside looks really good. So this is one I'm going to put up and on the workbench and actually use this, and not use a shelf, make it a shelf queen. You remember I did one a while back, another signal tracer, and that one, was more, I got a hold of it, really good deal, so that's the reason I snatched it up, restored it. But it's probably going to be a shelf queen. So far it's been a shelf queen. But this one, I want to use it as a daily driver. Now this model come out in 1952, just in time for holiday. 1952, so it's going on 70 years old. And they run these, the best I could do with my research, from 1952 to 1956, this particular model here. And they've got ones that got the gray face on it, and they got the ones that's got this more of a beige, whitish face. Well, not really white, but a lighter color anyway. And I always thought this one was really pretty, so I've been looking for one of these, and I got one. So I'm gonna clean it up and go through it here. Alright, so another thing different between this one and the other one, it's got, you don't see a headphone jack, it's actually got a speaker built into it, so that makes it real handy. And then sometimes, of course, doing a lot of troubleshooting, depends on what you're troubleshooting, the squeals and squawks you come down speaker can get a little bit of annoying, where really if you can just look up and see some indicator. And something modern, it'd be like a row of LEDs, or some sort of a TFT screen or something would show some kind of a movement. And I guess, of course, even back then they could have put an analog meter right here. But these was real popular back then as magic eye tubes, so they've use that. So this here, I can switch here and turn the speaker off if you don't want to listen to it, and just use this to tune it up, or to trace through your circuit. And you could also, with this off, use this voice coil output right here and drive an external speaker, or even use it for testing speakers. This device is pretty handy, as you're going to see here in a minute. The way it's set up. So I'm going to kind of start this one. I've got the schematic. The book came with it here, which is always nice. And this book is dated October 17th, 1952. So I'm going to kind of go over the front of the controls and what it does, and go over the schematic kind of at the same time, so kind of what I got in mind here. So let's briefly go over this. You got your speaker on and off like I talked about here. You got a high gain on and off switch, and that's going to here. This is what they're calling RF input. It's got another stage of gain in there. Your RF input comes in here and goes to this 12C8, just like in the other one had 12C8. This one's also using 12C8. Comes into the grid cap here, this 12C8. And then goes on to the rest of the circuit. You can see we got more stages of amplification. And then, of course, onto the speaker. But this one's got this, they're using this for their first high gain stage here. And these here is pretty much, as you can see here, this one comes out through the coupling capacitor. Or really, I guess, a blocking capacitor. It's letting the signal go through, but blocking the DC. And then this here coming through the switch on this, what they're calling the audio input. It's got its own capacitor here through the potentiometer and into the next stage. So with this switch right here, this is what they're calling high gain on and off. I can turn that off. And that's this switch right here. And what it's doing is it's blocking, or it's grounding the grid out to this tube, to the control grid in this tube, so it makes it quieter. Now, of course, this tube is still active and still going, so if you had some kind of problem with something in this tube itself, or what, some sort of problem with it, you're going to still pick up noise and stuff, so you'd have to troubleshoot that and fix that, because you want to make this device as quiet as possible when it's just turned on. There's going to be some slight hum to it, stuff like that, like it being tube and being, it's, the way it was designed back then. But you want it pretty much quiet. You don't want to hear crackling and popping without even testing something else with it, because then you don't know if it's coming from this or from that. So you should turn this switch off here. It's just grounding out, and so there's nothing coming in through this tube. And so you'll make sure this tube, of course, is good too. But that comes, like I said, here, and here's your what they're calling audio input. This goes straight in. There's your blocking capacitor, and through this VR here into the control grid of the 12SH7. And here's that potentiometer right here, that VR, called VR potentiometer, VR variable resistor, whatever you want to call it, right there. So that's right here. So it's from either side, either input. That'll vary the gain going into the next stage here. Let's see, and then we got well, we can just going through it here. Briefly just go through it, not whatever little tiny part does here, but then it comes out here. It gets amplified. This will amplify this, and this, was already amplified, and this will amplify it again, so this is your highest gain. But it amplifies the signal here and comes out and goes in through another capacitor into the control grid of this 12A6, which is driver tube for this voice coil for the speaker. So that would be a speaker here, and you got your voice coil outputs up here. That's what they're showing these two here are. And then something else they've done here, if you look, this is P and P here and the B plus in the middle. You've got primary of the transformer. That's what these two here are, coming right off, the front side of this transformer. And then you got a B plus in the middle. It comes all the way down from the first stage in the power supply chain here. So you get your highest voltage right there in case you want high voltage for whatever reason, for testing or whatever. So you got to be careful, reaching back in here and hooking stuff up if you was going to use this, because there's high voltage there, and this here says 200 and I guess that says 260. Probably be a little bit higher than that. Going right straight to this jack right here. So you got to keep that in mind if you're going to use one of these. And then this magic eye tube here, or 1629, which is up here. It'll pick it off right here before it goes into this, because you don't really need this, because this is really designed to drive this voice coil for the speaker. So you really don't need, to come off over here. You could, but you have to change circuitry and all that. So right here is just perfectly fine. Come up, goes through a 1 mega resistor, through the switch, into the grid there to control that magic eye, how much it opens and closes to the noise. So that's that there. And then this watt meter section here, we've got, if you look down here, and we've not talked about this yet, but this is just standard, got your line cord coming in through your high voltage side of your power supply, 6x5 rectifier tube. You get your voltage out, and then they're dropping it, and you see they got a capacitor to filter it more and more as it gets even farther back here to this highest gain stage. But this is standard power supply. Get your high voltages coming off, to feed your tubes. But it's also got a separate transformer. This is completely separate. It's not tied in with this here. Oh, and this transformer here, as you can see, also has got 12-volt winding center tapped for filaments, and they come off the center tap on one side for this 6X5, and then the other side where it says Y and X here. That's your X and Y's here. The 1629 is a 12-volt filament, and the rest of these are 12-volt filaments. But getting back to the watt meter, you get your line cord coming in here. You see one side's tied to one side of this transformer. The other side goes through this plug here to this side of the transformer, and that's that plug right here on the face of the unit. So when you plug in a load here, and depending on how much current it draws, how much load is on it, it's going to depend on how much this transformer is going to transform on this other side and impose a voltage over here. So, and what they've done here, they got a VR here. That's this one here to tell you watts. And they've got it calibrated on the face of the unit to you dial it up. You see they're coming off of here, off of this, because this 12C8's also got the 2 diodes in it. They're rectifying that to get their DC voltage right here on this potentiometer. And so that would come out here. It says A jumps up to here where A is. If you got the switch over here in watt meter, if you flip it all the way to watt meter, it would come in, and this here would be flipped over to here, so it would come in, and so this would work as for your watt meter. And what you do is you turn this until, like say you plugged in a 60-watt light bulb, and right here, you would turn this here. You can see my hand's in the way, but you turn that to, and if it's calibrated right, somewhere right about there. It ain't gonna be perfect, of course, because not only because this is an older analog device, even if you had a modern day, $10,000 unit that was tightly calibrated for wattage, and you take an incandescent bulb that says 60 watts on it, those things can be 55 to 65 watts. Because it depends on who manufactured them, how they was manufactured, how cheaply it was made, so on and so forth. So somewhere around in here, you should see that eye tube start to open. And when it just starts to open, that's where you read your wattage at. So, but a good thing is like if you got a 65 watt bulb or something like that, or 65 watt bulb, a 60 watt bulb, or 75 watt incandescent bulb, not none of these newer LEDs or anything like that. They're a good thing to use to calibrate this or make sure this is right. If not, you have to check the circuit out and see what's going on. But that's pretty much it in a nutshell. The whole schematic and the unit here. So, I was going to see if there was anything else I was going to say about this. While I've got the schematic out here, I'll mention this. If you've not seen it, if you go to YouTube and search for this particular model, you should come across one from Mr. Carlson's lab. And Paul Carlson done one of these. It's 2-3 years ago, something like that. He restored one of these on his channel. And he went in and made a modification right here, and I'll show you when I get it restored. I'm going to do the same modification. Because if you look right here, I'm not going to set everything up because he already done it. And if you want to see it, go and watch it on his channel. He explains it really well. He hooked the voltmeter up here where it says 90 volts. I don't know if you can see that, but that says 90 volts. It's supposed to be around 90 volts right here. Well, if you hook a voltmeter there, and you see this is kind of a silly way to bias this. They're bringing the signal in and trying to bias this tube at the same time through this VR right here. So when you bring this all the way down to 0, close to ground, this is way over here, down to 0, this is really going to pull, this down to hardly no bias. So this tube is going to start pulling heavy current. And I don't remember, but I've got to watch it myself again to see exactly how he set it up. I know he come out with a capacitor right here. He broke this and put another coupling blocking capacitor in right here. from right here, went to ground with a fixed resistor. But that resistor will be in the low mega ohm somewhere, probably. I don't remember what he used, but I know it was 4.7 or 5 or 6 mega ohm, something like that. And he went to ground with it. That way your signal will still pass through either side here. It'll come in, it'll go through that capacitor into the control grid. You can still check for noise, still use this unit just like it was intended. But if you turn the gain down, you're not going to shut the, bring this down to 0 on this grid, causing this tube to pull a heavy current. So I want to make that same modification he did, and I'll go over that when I get this restored. But this here, pretty sure that's going to be a waxy. Well, it is back in the day, so that's going to be changed out with safety capacitor. Of course, I'll change out all these capacitors because I want to use this every day. I want it to be reliable, so I don't want to. Well, maybe this is kind of working. I'll just leave it in there. Something like this, you just change capacitors out. They're cheap enough. Pull them all out, throw them in the trash, and replace it with new modern day equivalents. Alright, so there that is. Let me get this back off of it. It's got 2 screws in the back holding the back on. You take the 2 screws out, and this front will just lift out, separate from this case here. Pull it out, get this part out of your way. And looky there. I'm gonna interrupt my own self. I like where they've got Heathkit precision stamped in, into the metal there. But I'll get that done and set up, and we'll look at the inside of it. Okay. Well, I'm pleased to see that it had all the tubes in it. You know how many of these things I've pulled apart. Not this particular unit here, but old test gear, old receivers, old transmitters, old tube stuff that I want to restore or even think about restoring. You pull it apart and it's missing part of the tubes or all the tubes, or somebody's robbed an audio transformer, things like that. So this has got everything in it, so that's good. But you can see here with this jack coming in here, their high gain stage goes through this capacitor, through a piece of shielded cable here. Get that light a little bit more there. And to the grid cap of this 12C8, or it's a VT-153. And then your other jack here come in, and it goes straight into this tube here, as you can see right here, which is 12SH7. And then of course that would go into this 12A6 or a VT-134. I don't know without pulling it out if it's 12SH7's got a VT number on it or not. This one here is a lot of people call them JAN tubes, Joint Army Navy. So I have to check all these tubes. Here's your rectifier. Here's your main transformer coming in at high voltage to your rectifier. Goes through your filter caps. This has got 4 capacitors in this can here, and then out to the rest of the circuit. So let's turn it over here and look at the underside of it. If I can get this where I want to set this so you can see it. Let's just zoom in on some of it a little bit and move the camera around. If I don't drive you crazy, because I know when I watch people do these, I kind of like, man, I wish they'd zoomed in a little tighter to it. But here's the bottom end of that capacitor, that can capacitor. And as I've done other videos and stuff, I'm going to leave that in for aesthetics, just for looks. But I'll cut all these tabs completely loose under here and do whatever I need to do to replace it with the modern capacitors in here. If I have to use a terminal tie strip or whatever to add to it. Now the nice thing I'll notice about this, I'll show real quick. If you can see it here really good. All those tube sockets where that capacitor is, that's screws. You got nuts on the bottom here. So if you wanted to strip this chassis down and clean it really good, you know, because it's got some pitting on it and things like that, it'd be a lot easier than some of these are just all riveted on. When everything's riveted on, it makes it harder to drill those rivets out perfectly sometimes without accidentally hitting the side and scarring up your, you know, the chassis or whatever. So that would make it nice if you wanted to pull it, but I probably won't do it on this one. But definitely all these wax capacitors has got to go. Clean all these VRs and switches. This one here, that 10 microfarad 25 volt here. That one, that would be probably the cathode. You look at the schematic. Yeah, that comes off the cathode, that 12A6. That now be a little bit tiny, you know, capacitor that would go back in there, so I can tuck it up in there and I'll give him even more room in this area. Of course, these will be smaller too. All these here, so I can go through and make room to put in the 4 capacitors here for this can. And this one here, you can see it's kind of hiding back in there. This is the one going to the line cord that we changed out the safety capacitor. And I don't know if we can, let me turn this a little bit, see if I can zoom in, we can see that. Yeah, should be able to see that. I've noticed this is, like this here is Allen Bradley style resistor. But this 2.2 meg right here is what they call a roundy. So definitely have to go through and check all these resistors really good and see. They may be fine, they may not. It just depends on how this thing has spent its life, how much it's been used, or how it's been stored. Sometimes these roundies will be fine, and then sometimes they won't, and sometimes I'll just change them out anyway. It just kind of depends on how everything goes, and I go through restoring it. I'll bring the camera on down here. There's another roundy, and then that's Allen Bradley style, or like Ohmite, Allen Bradley. Of course, that capacitor there will go. You can see the wax on them peeling off and all that too. But so there's pretty much that. You can see everything there. I'll give it back out shot there and move this so you can kind of see it a little bit better there too. Change the light different ways here and give it more lighting. Get this all these capacitors changed out, check everything, clean this thing up. And let me see, yeah, you can see that. This grill on this front of this, somebody's pushed it in. Yeah, you can see how that's pushed in instead of flush. I'll probably pull this speaker off here so I can push that back out. It ain't going to affect the operation of the unit or anything like that, just for more aesthetics. But I want to set this up here and do it. And you know, I had one guy say, "Well, you worry about cleaning it up, you're going to set it on your bench and use it." He said, "Go in and clean your contacts inside." But well, when you, especially when you restore something, even if I wasn't putting this on YouTube, if I was just restoring it, I want to clean it up. I want to, and I've done a lot of things before I even started putting these on YouTube. I want to, you know, do the best you can, make it look good, clean up the unit as far as just general cleaning. And also clean up the contacts inside the switches. Change out bad components. Change out components that are iffy, or you know that from experience over the years that it might be working now, but it's going to go out. You just know they're going to go out. So don't even fool around with it. Don't mess around. Just change it out. Especially, if it's going to be something you're just going to clean up, fix up so it works, and set it on a shelf, maybe not so much, but when you got something that you're going to use every day, you want to set it up and put it on your workbench, you want to go through and make it just as good as it can be. And that's the reason I want to make the modification. It'll make it not as original when I make that modification. In there, I was talking about when I go and make this modification, but it'll make it that much better and make this that much quieter. It'll make it a little bit quieter. It'll make it easier on the tube, and it'll last longer. And I want to, set it there and use it. And this particular one I got didn't come with the probe, but a probe ain't nothing to the probe here. You can just run a straight wire in if you wanted to. RF probe ain't nothing to make one yourself. I don't even know if I'm going to even fool with it, because mostly I'll be using the active probe with this unit. So anyway, let me get this thing cleaned up and get some of these parts changed out and get it ready, and then we'll plug it in and fire it up together. So when I get that done, I'll be back.